Hello grade 10s, welcome to our second lesson on number patterns. I hope that the previous exercise made sense and that you were able to answer most of the questions, but I'm going to start by just going over the corrections from exercise 3.1 that you would have completed for homework. Okay, so if we start with number 4, we can see number 4 has the pattern 3, 7, 11, and 15. Okay, so I'm going to start by figuring out what my common difference is. Okay, so I'm going to say, well, T3 minus T2 should be equal to T2 minus T1. Okay, it's not always necessary to do it like this, where you do both of them, but I just like always doing it following this method because it also, while calculating the common difference, it also proves that there is a common difference, because remember, there's only a common difference if this whole statement is true. Okay, so it's just something that I do every time when I find the common difference. Okay, so if I say T3 minus T2, I will say, well, therefore 7 minus 3 should be the same as, well, it would be the other way around. So I would have 11 minus 7 would be equal to 7 minus 3. Okay, so you would have noticed that in both cases you would get 4. So therefore you can say, well, Tn is equal to 4n plus c. Then you can say, okay, well, my c value is T1 minus d. Okay, if you use another method to find c, it's perfectly fine. I just prefer using this one because it's just a bit quicker if you can remember it. But the first term is going to be 3 minus the difference, which is 4. So c is just minus 1. Therefore, Tn is going to be equal to 4n minus 1. I wanted to also show you that if you don't want to use this particular method for c, what you can also do is you can substitute into this equation here. So I'm just going to show you a second method that you can use as well. So you would have already been at this step here where you would have found Tn is equal to 4n minus c. Okay, that doesn't change. But what you can do is you can see, oh, well, I know that this T1 is actually 3. So you could substitute that in. You could say, well, T1 is equal to 4 times 3 plus c. And you know that T1, sorry, is not 3. It's going to be 4 times 1. But T1 is actually equal to 3. So all you have to do is you just substitute in 3 and 1 like a normal equation, because you know T1 is 3. And then you can just solve for c like that. So you would take the 4 to the other side and you would see that c is equal to negative 1 anyway. Okay, so it's just an alternative method. I'll try and maybe alternate between the two methods when going through the different questions. Okay, but you're more than welcome to choose. You can either do it like this or you can do it like this. Okay, it's actually very efficient to know both of them, just in case you end up in a situation where you might need one or the other methods. Okay, but in our case, both should work. Okay, then number 7. Okay, so you can see T3 minus T2 must equal to T2 minus T1. So we can see that negative 5 minus 0 is equal to 0 minus 5. So then negative 5 is equal to negative 5. Okay, you must show, I know that in this case it's a bit easier to see that the difference is negative 5. Okay, so it's not really, you can skip this if you would like and just go straight into d is equal to negative 5. Okay, it's just that you can also use this method just so that you can make sure that you don't make any mistakes. But you are more than welcome to jump straight into the fact that the difference is negative 5. That's fine. So Tn is equal to negative 5n plus c. Okay, I'll use both methods. So the first thing I'll say is, well, c is equal to t1 minus d. Term 1 is 5 minus the difference, which is negative 5. So 5 plus 5 is going to be 10, which means that Tn is equal to negative 5n plus 10. Okay, the alternative method would be to say, well, Tn is equal to negative 5n plus c. T1 would equal to negative 5 times 1 plus c. But we know that T1 is actually 5. So 5 is equal to negative 5 plus c. So then you take the negative 5 to the other side, it will become 5 plus 5 is equal to c. So therefore c is just 10. Okay, both methods would work. Okay, then the next one. Just want to move so that we have a bit more space. Okay, so for the first one, we can see it's negative 6, negative 11, negative 16. So the common difference here, I'll go a bit quicker here. You can write out the full T2 minus T1, which is T3 minus T2. That's fine. I'm just going to be going a little bit quicker because hopefully by now you should be able to get the common difference. Okay, so you should be able to see that the common difference is subtracting by 5. Okay, so the common difference is going to be negative 5. So if Tn is equal to negative 5n plus c, you can use either method. I'll just use the one, which is going to be c is equal to negative 6 minus negative 5. So then the c value is just going to be negative 1. So therefore Tn is equal to negative 5n minus 1. Okay, the next one. Now with this one, it's up to you. You can convert it into improper fractions if you want to. Okay, it's not really necessary to do that. You don't have to really do that in this case. And actually, in this format, it should be quite easy to see that all you're doing is you're just adding a half every time, which means that your difference is going to be positive a half. So you know, well then Tn is equal to a half n plus c. Now you need to figure out what c is. I'm going to do the substitution method. So I'm going to say, well, T1 is equal to a half times 1 plus c, but T1 is 3.5. So 3.5 is equal to a half plus c. Then you'll bring the half to the other side. It'll become negative a half, and you'll be left with 3. So therefore Tn is equal to a half n plus 3. Don't forget, obviously, that you need to find Tn. So make sure that you don't forget that final step of actually finding Tn. Oh, I see that actually the question also wanted to know T100. So let me just go back to number 4. Okay, I'll do this one in orange so that it's a bit easier to see, okay, which one's this one. So we would say that T100 would equal to 4 times 100 minus 1, which is just going to be 399. For this one, it also wanted to know T100. So T100 is going to be negative 5 times 100 plus 10. So then you'll just put that all in your calculator and you should get negative 419. Okay, for number 9, T100 is going to be negative 5 times 100 minus 1. You put the whole thing in your calculator and you'll get T100 to be equal to negative 501. Okay, for this one, you can see that T100 is going to be equal to a half times 100 plus 3. Half of 100 is 50 plus 3 is just 53. Okay, so moving on, we're going to do number 13. So number 13 says 2.5, 4.5, and 6.5. Okay, so hopefully, again, you can convert it into an improper fraction. It is fine, but I'm sure that if you look at the common difference, you can see that the half is staying the same. So all you're doing is you're just taking it and you're multiplying by 2. So the difference, well, not multiplying, that you're adding to every time. So if I'm just adding 2 every time, I can see, well, the common difference must be 2. So Tn would equal to 2n plus c. Okay, I'm going to do the first method, which is c is equal to T1 minus d. T1 is 2.5 minus the difference, which is 2. So you're going to be left with a half. So then Tn is equal to 2n plus a half. So T100 is 2 times 100 plus a half. So in this case, you can leave it as an improper fraction, it's fine. But it's more than acceptable to say, well, 2 times 100 is 200, plus a half would be 200 and a half. Okay, there's no need to, you can leave it like this if you want to. If you are uncertain and you don't really want to leave it like this, you could also leave it as 401 over 2. It's also okay. Okay. Now, I would just specifically mention that if the question gives it to you as mixed numbers, then it's preferred that your answer is also a mixed number. So as much as this is also acceptable because it's not wrong, I mean 401 divided by 2 is 200 and a half, but just for formatting purposes, we want to match the question to the answer. So that's going to be like something like if we look here at 15. Okay, it's preferable that now that they're giving you decimals, that you'd also try and keep all your answers in that decimal format as well. Okay, it's not, like I said, it doesn't necessarily mean it's wrong to do fractions, but we keep to the format. Okay, so please just remember, you can even make a note of it on the side to say keep to the questions format. Okay, it's just a better way to do math. Okay, so let's have a look. So we can see, well, the common difference here, all I'm doing is I'm just going to be adding 0.2 at each point. So the common difference I can see is 0.2. So if Tn is equal to 0.2 n plus c, I'm going to use the substitution method. So I'll say, well, T1 is equal to 0.2 times 1 plus c, but T1 is 0.5. So 0.5 is equal to 0.2 plus c, so therefore c is just going to be 0.3. if you actually picked up, you would have seen that although I call it two methods, it's still basically the same method. It's not like it's really that different. Okay, so I can see Tn is equal to 0.2 n plus 0.3. So if I want to find T100, oops, just want to make myself some space. So T100 will be equal to 0.2 times 100 plus 0.3. Okay, you can put it in your calculator and give it as a decimal, which will be 20.3. Okay, remember, leave it as a decimal because that's the format of the question. Okay, then number 18. Let me just make some more space. Okay, so I'm going to do 18 over, I don't want to move on to the next page yet, so I'll do 18 using the whole bottom of this page if I need it. Okay, so 18 is minus 13, minus 7, minus 1. Okay, so you can see that this one I don't think I copied down the right one. No, that's number 16. Number 18 is 13, 12, 11, and 10. Okay, so if you notice, you'll see, well, at each point, all you're doing is you're just subtracting 1. So you know your difference, it's negative 1. So if Tn is equal to negative 1n plus c, then you can see, okay, well, your c is just T1 minus d. So T1 minus d is going to be, c is equal to 13 minus negative 1. So your answer is going to be positive 14. Okay, don't forget your signs. So that means that Tn is equal to negative n plus 14. Okay, remember we don't say negative 1n in the final answer because that's just not how we do it. Like we don't say 1x, we just say x because we know that there's a 1 in front of it. Okay, then T100 is going to be equal to negative 100 plus 14. So negative 100 plus 14 is just negative 86. Okay. Now, B. B and C. So B and C was a two-part question. It asked you firstly to find the term of something, and then it also told you to find which term in the sequence was something else. Okay, so the first question, number 1, says determine the 45th term. Now, in order for us to determine the 45th term, we have to start by finding what Tn is. Okay, because you can't find the value for T45 until you first have to have the value of Tn. So Tn is equal to Dn plus C. I can see the difference is that I'm just going to be adding 7. So Tn is equal to 7n plus C. So 4 would be 7 times 1 plus C. So C is going to be equal to negative 3. So therefore Tn is equal to 7n minus 3. And now you can find T45. So you say T45 is equal to 7 times 45 minus 3, which is just 312. Okay, so the second question, the second part of the question asked you, it said, which term in the sequence is equal to 627? So they told you that Tn is equal to 627, and then they said which term, so they want n. So we'll say if Tn is equal to 7n minus 3, but I know I want 627, I want to figure out what the n is. I start by adding 3, so I'll have 630 is equal to 7n, so then n is just going to be equal to 90. Okay, so we'll conclude our statement and we'll say T of 90 is equal to 627. Okay, it's better to leave your answer like that than just leaving it there. Okay, so let's look at C. Again, the first question asks you to determine the value of the 65th term, but you can't do that until you have Tn. So Tn is equal to dn plus c. You can see the difference is I'm just subtracting by 3. So Tn is equal to negative 3n plus c. Then you can substitute in, so I'm going to say 19 is equal to negative 3 plus c. So c is going to be positive 22. So therefore Tn is equal to negative 3n plus 22. Now you can find T65, which is negative 3 times 65 plus 22. So T65 is just going to be negative 173. Okay, the second part of the question asked you, it said, which term in the sequence is equal to negative 113? So Tn is negative 113. They want you to find n. So 113 is equal to negative 3n plus 22. So you'll start by adding 22 on both sides. So you'll get, therefore, 135 is equal to negative 3n. So therefore n is just going to be positive 45. Okay, you divide both sides by negative 3. So therefore T of 45 is equal to negative 113. Okay, easy enough. Both questions use the exact same methods. Okay, now G. G is the more complex ones, like we were doing in that last question. Okay, so firstly, I can see that G has the pattern x plus 2, 4x is the second term, and the third term is going to be 6x plus 4. Okay, so the first question says determine the value of x and hence the sequence. Okay, so the value of x I'm going to find by using the common difference. So I'm going to say, well, if this is T1, that is T2, and that is T3. The common difference says that T2 minus T1 should be equal to T3 minus T2. Okay, it doesn't matter in which order you do it. Okay, either way you'll still get the exact same answer. in terms of this side being on that side or this side being on this side. Remember, it's equal, so it doesn't matter. Okay, so T2 is 4x. Don't forget your brackets. Let me actually do it in a different color. So it'll be T2 minus T1, which is equal to T3 minus T2. Okay, we must put our brackets because of those signs. So I have T2, which is 4x, and T1, which is x plus 2. T3 is 6x plus 4, and T2 is 4x. Okay, then let's continue solving. So I'll have 4x minus x minus 2, which is equal to 6x plus 4 minus 4x. Okay, so then you can group everything to one side. So you'll have 4x minus 6x plus 4x, which is equal to 4 plus 2. Okay, 4x minus x is 3x, minus 6x is going to be negative 3x, plus 4x is just x, which is 6. Okay, so then it asks you, it said determine the value of the sequence, the different terms. So we're going to rewrite it, x plus 2, 4x, and 6x plus 4. Okay, then you substitute 6 in the place of x. So I have 6 plus 2, 4 times 6, and 6 times 6 plus 4. So my final answers then is going to be 8, 24, and 6 times 6 is 36, plus 4 is 14. Okay, that's number 1. Then number 2, just asked you, it said, what is the value of the 160th term? So it said, what is T160? So again, in order to find T160, we first need to have Tn. So Tn is equal to dn plus c. The difference I can see is just adding 16. So Tn is equal to 16n plus c. Then I can just substitute. That's 8 is equal to 16 times 1 plus c. So then the c value is just going to be negative 8. So therefore, Tn is equal to 16n minus 8. Now they wanted T160. So we'll say, well, T160 is going to be equal to 16 times 160 minus 8, which is equal to 2,552. Okay, make sure that you go over this, okay, if it was something that you struggled with, but I'm pretty sure that you can see that it's very similar to what we did in the examples in the previous lesson. Okay, so H follows the exact same format. The first one is to now find the common difference. So I'm going to say, well, 2x minus 4 minus 6x plus 8 must equal to x minus 4 minus 2x minus 4. Okay, it's just T2 minus T1 is T3 minus T2. Okay, you're going to simplify this, so you'll have 2x minus 4 minus 6x minus 8 is equal to x minus 4 minus 2x plus 4. Be careful there of that sign. So you simplify the left hand side, you'll have minus 4x minus 12 is equal to minus x. Therefore, minus 3x is equal to 12. So therefore, x is just going to be negative 4. Okay, if you substitute that in, okay, I'm not going to do the substitution. I'll just give you the final answer because I'm sure you can substitute. You'll have negative 16, negative 12, and negative 8. Okay, then the second question asks you to find, it says, which term of the sequence will be the first positive term? So in order to figure that out, we need to get Tn. Okay, we can't figure out any term unless we know the general rule. So we'll say Tn, the difference here I can see it's getting bigger. So I'm just going to be adding 4. So 4n plus c. So negative 16 is equal to 4 times 1 plus c. So c is just going to be negative 20. Okay, so I can see Tn is equal to 4n minus 20. Now the question asks you which term in this, it said, which term in the sequence will be the first to be positive. So if you can remember, if the term, this is the term, Tn, is going to be positive, then Tn must be greater than 0. So that means that 4n minus 20 must be greater than 0. And then you'll just solve for your inequality. So you have 4n positive 20, so n, it must be greater than 5. So you have to answer the question. It said which term will be the first positive term. So the first positive term must be have an n value that is greater than 5. So the nearest whole number that's bigger than 5 is going to be 6. Okay, don't forget this step. Okay, you can't leave it here. You will lose 1 mark because the question specifically asked you which term is the first term to be positive, and it's the 6th term. Okay, so the third question says, which term of the sequence will be the first to be greater than 110? Okay, this one you can see that we're just going to follow the exact same format as we just did. So they said which term is going to be greater than 110. So that means that I'm trying to find where is Tn going to be greater than 110. So we just follow the exact same rule. We said 4n minus 20 must be greater than 110. So therefore 4n must be greater than 130. So n must be greater than 65 over 2. Okay, remember you can put this in a decimal format or you can put it in a fraction format. It's up to you to figure out exactly where this lies. Okay, but n is essentially supposed to be greater than 32.5, or n must be greater than 32,5. So therefore n is going to be 33. Okay. So that is all the corrections from the questions that we went through. Okay, so essentially all you need to do now is I'm going to give you some more questions from the same activity. Then you can complete that for homework, for additional practice. Okay, so your homework is going to be from the same exercise, exercise 3.1 on page 66. Okay, you're going to do number A. Let's do number 14, 16, and 17. I want you to do number D, number F, I, and J. Okay, so that concludes our video for today. Okay, so our next lesson we'll be going over some applications with number patterns, but essentially we are nearing to the end. It's not a very big section, so it is something where you can score marks, but it's not too many marks. But because it's not that much work in terms of the difficulty, it's essential that you get as many marks as you possibly can. Okay, but that essentially concludes today's lesson. I hope that you enjoy the rest of your day, and I'll see you on the next one. Bye bye.